everyone. In this video we are going to work through two examples of an entire linear programming problem, and then I have a third example which I will leave for you if you would like to practice on your own and discuss some of those steps. Okay, so we have 5 steps to work through, and here's the problem. A teacher makes leather purses and cloth purses in her spare time. She can make at most 20 purses per week. She plans to make at least 5 leather purses and no more than 15 cloth purses. Her profit on a leather purse is $5, profit on a cloth purse is $10, and the question is, how many of each type should she make to maximize her profit? Alright, so first of all, step 1, we need to write the objective function. So she's trying to maximize the profit. So this is going to be a profit equals, alright, and then it's going to be something x plus something y. So we need to also identify the variables. Okay, I will go in order of how these things are mentioned in the problem. So we have leather purses and cloth purses. I'm going to have x be the leather and y be the cloth. Alright, so profit, I want to go through and look for the profit for each one of these. So we're told profit for a leather purse is $5, so this is going to be 5x plus, and then the profit for cloth is going to be $10, so 10y. 5x plus 10y, that's her total profit from leather and cloth purses. Step 2, write the constraints. Okay, now I'm going to cross out this sentence. We're completely done with this. We're also done with the sentence telling us to find the number of things to maximize the profit. I can cross out the first sentence. That's kind of like the setup. So all of the constraints are going to be in the 2 sentences that are left. She can make no, or at most 20 purses per week, and at least 5 leather purses, no more than 15 cloth purses. So let's get some constraints out of that. At most 20 purses per week. Okay, at most is no more than, or in other words, less than or equal to 20. Now it doesn't specify leather or cloth purses, so we actually mean the total here. The total of leather and cloth purses is less than 20. So this is going to be an x plus y, leather plus cloth. Okay, so that sentence is done. She plans to make at least 5 leather purses. All right, so at least is greater than or equal to, and it's the leather purses, so x, the leather purses, however many she makes, is greater than or equal to 5, okay, and no more than 15 cloth purses. So the y, the cloth purses, is less than or equal to 15. Alright, now the only other thing we need to do for constraints is those implied ones. X is greater than or equal to 0. I can skip that one because in this case I already know that x is greater than or equal to 5. I've already specified a minimum value for x. That ensures that it's not going to be a negative value. I haven't done that for y. I've stated a maximum value, but I haven't said how small y can be. So the only other implied constraint that I need is y is greater than or equal to 0. Step 3 is graphing. So I want to graph x plus y is less than or equal to 20, x is greater than or equal to 5, y is less than or equal to 15, and then y is greater than or equal to 0. That's going to guarantee that I'm staying in that first quadrant for the graph. So let's do intercepts on the first one. X plus y is less than or equal to 20. So I have the points 20, 0, and 0, 20. Okay. Then these guys are going to be horizontal and vertical lines. So if I look at the scale here, it looks like I need to go up to 20 for x. That's the biggest value of x that I have. And then the biggest y value is also 20. So I'm going to make kind of a square graph, or at least I'll be using a square amount of space. Okay, and I've got lots of space here. I could go by ones, but I think I'll go maybe even just by twos here. So this would be like 2, 4, 6, 8, 10, and I'm just going to mark some of these. Okay, 12, 14, 16, 18, 20, and same thing on the x-axis. And I'll just mark kind of like the 10s and 20s. Alright, and you can choose to make yours larger if you like, but I'll just do this for now. Okay, so x plus y is less than or equal to 20. I know the intercepts are the 20s. I'll connect those with a line. Let's see. There we go. Make sure it's a blue line. Okay, that's going to be my blue equation. X is less than or equal, or greater than or equal to 5. So I need a vertical line at 5 for x. 2, 4, and that's going to be kind of right. Okay, close enough. Okay, so there's 15. And greater than or equal to 0 for y, I've got that. Alright, shading, I need to stay, let's see, a test point, I need to stay below the blue line. Alright, I need to stay above, let's see, oh, to the right of the green line. Okay, and then the red line below that. Alright. And I think I need to shift this green line. This is off a little bit. Okay, let's see. That I think is closer to 5. Okay, that looks a little better to me. Okay, so if I look at where to shade, the one thing that makes me a little nervous is this kind of weird region here. I want to make sure, it looks like that's actually one point, but I want to make sure I don't have like a really tiny triangle in there, and I want to make sure I'm shading the right thing. So first of all, if you notice look at the green and the red lines. So we're going to try to find the coordinates of where those intersect. So the green line, that's x equals 5, so an x coordinate of 5, and then the red line, that's y equals 15. So that's the point 5, 15. Now the question is, does the blue line actually go directly through that point, or is it, off just a little bit? So if you look at the blue equation, x plus y equals 20, 5, 15 is a solution to that. So that all is a single point there. Okay, I'm not imagining that. This is, now accurately drawn for the most part. So if you look at the shading, it's actually going to be in this triangular region, and it's only touching the red line exactly at that point. So really, I actually didn't even need that red line constraint. I think I would, yes, I would still have the same shading even without that. So sometimes the graphs will look a little bit different than expected or than some of the examples we've done. So just double check and make sure that you have graphed everything correctly, that you do have the right vertices and the right sides for shading, and then just be aware that you could end up with kind of an unexpected region like this. Alright, so the vertices. I do have this one, right? I showed you how to find that. This blue one down here, I know because that was the intercept of my blue line, that's the point 20, 0. And then back here at this green line, I know that one too. I know the x-coordinate from the green line, that's 5. And it's intersecting the axis there, so that's 5, 0. So this is a problem that just has 3 vertices to check in the objective function. So I'm going to take those back to this p function and plug those in. Okay, so step 3 was graphing, step 4 was finding the vertices, and step 5 is substituting them in. So I want to do 5 times, alright, so I'll do 515. Okay, and then I have 2 more. Okay, we've got 5, 0, and 20, 0. Alright, so what's the profit associated with each of those? Well, the first one, that's 25 plus 150, so that's 175. The next one is 25, and the last one is 100. So let me go back to this question here. What were we supposed to answer? How many of each type of purse should she make to maximize the profit? And I'll usually add on to this and also ask you what is the maximum profit. So in this case, your answer would be the maximum profit is $175. And then how many of each type of purse? So here we would just want to interpret this point, okay, the vertex that goes with that maximum profit. So she should make 5 leather purses, because X was leather, and 15 cloth purses in order to maximize the profit. Alright, a second example. Let me at least walk you through the first couple steps. Okay, so an automobile dealer has room for no more than 100 cars on his lot. The dealer sells 2 models, convertibles and sedans, and he sells at least 3 times as many sedans as convertibles. If he makes a profit of $1,000 on a convertible and a profit of $1,500 on a sedan, how many of each car should he have on his lot in order to maximize his profit? So step 1, we're writing the constraint, maximizing the profit. We need the 2 variables, X and Y. Alright, so he's selling convertibles and sedans. So let's have X be the convertibles and Y be the sedans. Okay, so the profit for convertible is $1,000. Okay, so 1,000X plus, and the profit for sedans is 1,500. 1,500Y. So that's the objective function. Constraints. Okay, he has no room for no more than 100 cars on his lot. So this is a total of both of them, convertibles and sedans, no more than 100. So this is one of those X plus Y, alright, the sum ones. And the sum of X plus Y is no more than 100, so less than or equal to 100. The next limitation I see, he sells at least 3 times as many sedans as convertibles. So I know that there's a 3 in there, 3 times. The question, I'm just wondering, is this X and 3Y or Y and 3X? So this is one of those problems where you might want to try specific numbers. So pretend that he sells exactly, not at least, 3 times as many sedans as convertibles. So if I make a little chart here, sedans and convertibles. Okay, which one is he selling more of? It's 3 times as many sedans as convertibles, so definitely more sedans. So let's say that I have, he sells 10 convertibles. 3 times as many sedans would be 30. If he sold 20 convertibles, 3 times as many would be 60 sedans. So there's some sample numbers. Okay, so if I do the trick, okay, kind of line these up, have the X on one side, and ooh, I think here we said X is convertibles. Okay, so if I do 10, the X on one side, and 30 for Y on the other, well, where do I need to put the 3 to make this a true equation? Well, it's got to be with the 10, the smaller number. Okay, so 10, that's convertibles, that's X, and 30, that's Y. So I'm putting the 3 with the X with convertibles, the smaller number, to balance it out and make that equal to the larger number of sedans. Okay, so it's 3X and Y. Which direction does the inequality symbol face? So now let's pretend, okay, we're not pretending anymore that it's exactly, or 3 times as many sedans, but now we want to realize that it's at least 3 times as many sedans. So there's no upper limit on sedans, so, you know, instead of 60 and 20, it could be like 120. So let me fill in those numbers for X and Y. So 100 for Y, and 3 times 20 on this side. Okay, so I have 160, and then the inequality symbol goes this way. All right, so Y is the number of sedans, and there's no limit on that. That's got to be greater than or equal to 3 times the number of convertibles. All right, so that's a second constraint. That's everything that's mentioned in the problem. So then what's left to do for the constraints is to look at the implied ones. And here I don't have a minimum for X or Y, so I'm going to throw both of those in. He can't sell negative numbers of convertibles or sedans. They're both going to be greater than or equal to 0. Okay, how about the graphing step? We might as well just finish this one. Okay, so let me look at the intercepts again. All right, I've got X plus Y. Oops. X plus Y is less than or equal to 100. Y is greater than or equal to 3X. Okay, so this one, the intercept points are 100, 0, and 0, 100. So I need a little bit larger scale on this one. All right, I could use slope-intercept form for Y is greater than or equal to 3X, so that's already in the correct form. So let me set up the axes. All right, and for a scale, maybe we want to go by tens. So I'll do each single line as 10. Okay, here's 20. And I'll just mark off a few of these initial points. Oops, that's not right. 10, 20, 30, 40, we'll do 50. Okay, there we go. All right, so I actually need 100. All right, on each axis. All right, so there we go, and I can connect those. Shading, if I test 0, 0, I have 0 is less than or equal to 100. That's true, so I'm going to stay below that line. And then here, now look what happens. This is Y, and if I temporarily pretend that's an equal sign, Y equals 3X plus 0. So I have Y-intercept of 0, that's down here. And then a slope of 3. If I'm going on a scale of 10 here, if I go up 3 and over 1, that's going to be a little bit hard to see. So it's handy to actually know that for fractions, instead of looking at 3 over 1, you can also do multiples of this. So I could also look at 30 over 10 if I wanted to, or 300 over 100. Right? So instead of going up 3 and over by 1, I think it makes more sense to go up 30 and over 10, since I'm, using a scale of 10. So I'm going to go up to 30 and over to 10, and then I will go up 30 and over 10 a few more times just to find some other points. And then I should be able to graph a fairly accurate line here. Okay, so there we have it. Shading. This time I can't use 0, 0 as a test point because that's actually on the line. So instead I'll choose something else. Maybe I will choose the point 20, 0. 20, 0. Alright, so I end up with 0 for y is greater than or equal to 3 times 20. 0 is greater than or equal to 60. That's false, so I need to shade the opposite side of the line from this 20, 0 point. Okay, and then x and y are both greater than or equal to 0, so that's telling me to shade within this first quadrant. So if I put all 4 of those arrows together, I end up with this as my feasible region. Okay, vertices for this. Okay, well I know 2 of these already. This was the point 0, 100, and I knew that from graphing the line. This is the point 0, 0, and then I just need the intersection of these 2 lines. So I might try substitution here. I know that, okay, so I'm going to pair these 2 together. Pretend this is an equal sign. Okay, and then I'm going to substitute 3x in place of y in the first equation. Okay, since y equals 3x. Okay, so we get 4x equals 100. Divide by 4, x equals 25. And then since y is 3 times x, I know that y is 3 times 25, or y is 75. So that point is 25, 75. All right, so I have 3 points to test in the objective function. Okay, so I'm going to go back to this profit function and plug in my 3 points. So 0, 0. Okay, that's going to give a profit of $0. Then I have 0, 100. And that's going to give a profit of, oops, there we go. Okay, $150,000. And then the point 25, 75. Okay, 25, 75. And that's $137,500. So the maximum profit is actually $150,000. And how many of each car should he have on his lot? He should have 0 of X, which we said was convertibles, 0 convertibles, and 100 sedans. So in this case, the sedans were more profitable, and it was allowed within the restrictions to have that maximum number of sedans. So, right, so we want to have as many sedans as possible. All right, I have one more example which I will leave for you to try on your own, and you can use this as a discussion question. Okay, that's it for solving linear programming problems. So review those 5 steps. Okay, so we always start with writing the objective function, then writing the constraints, then graphing, finding the vertices of the feasible region, and then finally plugging those into the objective function and answering the question. All right, thank you.